Hi, yeah, I'm Chris. I am one of the core developers on Compute, as we just saw. I wanted to zoom in today on kind of serialization in Compute. For one, because I don't think it'd be really a parcel fest if there wasn't a talk about serialization, although I'm never going to replace that on that. Um, and two, this is just stuff that I've been working on all throughout the year, and I think there's some features here that I also think people aren't really realizing are there and are taking advantage of. So everyone knows what serialization is, but I'm just going to go over this really quickly, what we're dealing with. Compute, we have two things that we're serializing. We're serializing the actual code itself to run. We're serializing the data that the code will be running on, the args and keyword arguments. Um, that's very similar to what Parcel is doing, of course. And like Parcel, we rely on Pickle. Um, as we all know, it's a language in the sense that it's a stack-based language for reconstructing the code objects in Python, not a format like JSON or YAML. Requires a similar environment in both execution, Python version, in terms of the packages that are available, which all makes it extremely awkward in a remote environment. It's great for Parcel, kind of terrible for Compute, but we rely on it that we have to. Very customizable, which makes it really easy to make malicious payloads, something that Ben likes to talk about a lot as well. And then like Parcel, we rely on DIL, which is just a library of extra protocols for Pickle to use. What Compute has that Parcel doesn't have is this idea of a serialization strategy, which is a recent addition of the last couple of years. They are in charge of actually turning the data to be serialized, the code objects, into actual strings for usage. So I'm sure you're all familiar with DIL code, combined code. Those are by far our most popular. 40% of people are using combined code. That's almost certainly because it's what pops up in the error when you see that there's a serialization error. But I think there's some really cool new ones that we've added, such as pure source, the two those that are in bold, and JSON data that really are underutilized. And I think people should, really fill in some use cases that other ones don't fill in. I'm going to get into the pure source ones later. JSON data is very self-explanatory. Anything that's JSONable, it turns into a JSON string, as opposed to our default DIL data stuff, which DILs everything and then turns it into base 64 for string representation. So DIL is great for arbitrary objects, but obviously causes a lot of issues when it comes to serializing on different versions between the serializing and the deserializing. JSON's a great way around that. I mentioned on the previous slide, please look at our docs. Our docs are really nice now, like Josh mentioned. We have these beautiful little tables that show you exactly what all our serialization strategies are get at. So definitely take a look at that if you haven't. This is what it looks like to choose a serialization method. As you can see, you instantiate a new client, you add your code and data serialization strategy, but we've kind of smoothed out some of the way that this works now. I went back, I didn't mean to. We've smoothed out how this works now in that now you can pass things directly to your executor. You don't have to pass in a client object or even create a client object. So nice little API service detail that's a little easier to work with. I mentioned I would go into more detail on these pure source guys. So this is what the payload of our current DIL code source serializer would look like. If you're just doing a very basic hello world here, and you are serializing that with our DIL code source method. The claim of this is that it is serializing the source code, and it does do that. But that source code is wrapped up in this DIL and base 64 encoded string. And we're introducing DIL where there really doesn't need to be DIL. So we have these new pure source methods. As you can see, we're actually serializing the method of the string here directly. There's no extra encoding layer on top of that, just sending the raw string bytes over the wire. That should also be another thing that's huge in terms of reducing version mismatch differences. There are two pure sources. There's DIL, which gets the source using DIL library. It doesn't serialize anything using DIL. It just uses it to get the function, the code. And then there's also a text inspect version. Another thing that's new as of last Parcel Fest is allowing different serializers, like having allow lists of serializers. So I'm not going to go into how easy it is to construct malicious payload with DIL. Again, that's Ben's wheelhouse. But if we can imagine that this malicious payload right here is constructed with some class that's some kind of arbitrary code execution thing going on. Because this uses deal by default, our allowed serializers, the way that this works, it really very simple. The serializer checks the serialized payload against the header. That's the start of all of our serialized payloads. You can see that header right here, in fact. For source code DIL, it is SD. For DIL code source is 04. So we're literally just checking the payload at the tag at the start of the payload to see if it's within one of these allowed deserializer types, and raises a nice little deserializer error if that's something that you don't want to happen. Even better though, that's great for users. If you are an admin and you don't want to deserialize untrusted user data, this is what the whole purpose of this is for. And we have these wildcards that you can use if you want to allow any kind of code. Say you've got some kind of function allow list, and you trust all the functions that you've serialized and registered yourself, but you don't trust user data. This is a great way to prevent arbitrary function, or sorry, to allow those functions, but prevent arbitrary data from being deserialized. Another thing in a similar vein is result serializers, which allow you to specify to the endpoint exactly how you want your results to be serialized back to you. So in this case, submitting to an executor using the JSON data, results are going to come back as JSON. This is actually, with this plus allowed serializers, you can now, or with selectable serializers, I should say, you can now have a submit that uses no pickle, no dill whatsoever. JSON data to serialize your data, pure source text and spec to serialize your stuff. Really good actually for building out APIs that rely on a lot of control over serialization. I think that about, yeah. So wrapping it up, things that we're moving on and forward. Josh already mentioned pluggable serialization in Parcel. Something that Reed has been working on is this idea of serializing an entire module of Python instead of just serializing the code itself. That'd be very similar to our existing pure source things, but it would require a different API surface because compute is all about submitting the function. Now we're submitting a whole file. So that's very much in the works. Yeah, pluggable serialization in Parcel. Do we even want to give you the ability to bring your own serializers? Right now, you have to use Globus Compute supplied serializers. We have a lot of checks for that. But if anyone has any workflows that involve custom serialization, we would be all ears on that. That could be very interesting for us. But that's all I have.